everyone, and welcome to Pale Blue Pod. This is the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. And I'm your host. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe. And today I'm joined by someone who I suspect might also be a friend to the universe. I'm joined by actor, podcaster, and bunny parent, Bex Taylor-Klaus.
Hello, I am indeed a bunny parent.
That's one of my favorite things that I know about you. The first thing that I knew about you, actually.
It may be the best thing to know about me, honestly.
Yeah, I was looking you up so that I could have like an intro for the episode, and I was like, oh, you're an actor?
Right? That's less interesting.
I thought you lived with bunnies.
I just live with bunnies professionally. I'm still working on how to get paid for that, but yes.
Okay. Yeah, One day it will come.
Capitalism sucks, but bunnies rock.
That should go on a poster.
Mm-hmm.
Is there anything else you would want the listeners to know about you before we get started?
Actor, podcaster, and bunny parent is the best way to describe me that I've ever heard, and I think I should put it on a t-shirt.
Great. I've nailed it. Love that. Awesome. Well, listeners know that we record every new episode of Pale Blue Pod in a cozy, comfortable location. Bex, can you describe where we're recording today?
This is the queen's den of an active beehive.
Oh, it smells so good.
Mm-hmm.
It smells so good, and there's a very pleasant buzz. Did we shrink ourselves to get in here?
Actually, it's an extremely giant beehive. Don't worry, the bees are friendly. They're very, very friendly.
Great. Oh, I wasn't worried about the bees. I grew up on an apiary, actually.
You are so cool. Every time I learn something new about you, you're even cooler.
Ditto. My dad was a beekeeper, and every year during honey harvesting season, he would bring the hives inside the house.
Awesome.
And he would take the slats out of the hives and put them in this giant centrifuge to spin all the honey out. It was really cool.
Honestly, it's probably the greatest smelling vomit of the entire universe.
Yes. Yeah, that was the original marketing campaign, wasn't it?
Should have been.
Okay. Well, hopefully we can see some drones and some workers moving around. Do you think we'll get to meet the queen later?
I hope so. I feel like she's probably dressed in the most fancy of fancy garb, and I want to see it.
Oh, yeah. Okay. Well, I think that we'll do that after we record the episode for sure.
Sweet.
So today we're talking about the Alpha Centauri system. This is a topic you picked, Bex. What's the connection there?
You want to know the truth? I have some oracle cards that are sky map, solar system, astrology, less astronomy, but also a little bit of astronomy based. Mm-hmm. And the card I pulled was Alpha Centauri.
So you literally pulled a card to figure out what we were talking about today?
Yeah, more or less. I pulled the cards because they make me happy, and I like looking at the stars, and the easiest way to look at the stars when you're surrounded by light pollution is in the cards.
Yeah. Yep.
So
the cards are the screen. That's what I do.
Exactly. And so I pulled a card, and then when I was looking through your list of possible universe things to learn about, I saw Alpha Centauri, and I was like, wait a minute. I literally pulled this like half an hour ago, completely unrelated. Now it feels related.
Yeah. Oh, I love that. Is there anything that you would like to know about the Alpha Centauri system before we finish this episode?
I want to know why it's called Alpha Centauri, and if it doesn't have to do with centaurs, I'm going to be sad.
Oh, I have good news for you. It does.
Oh, yay.
Yes, it does have to do with centaurs. Okay, I'm glad I could clear that up for you right off the top.
I'm so excited.
Well, I have a lot more information about the Alpha Centauri system, but before we get to that, I do want to learn more about you. The listeners want to learn more about you. So everyone who comes on to Pale Blue Pod has to take the preliminary entrance exam to Pale Blue Podiversity.
Excellent. I'm terrible at taking tests. Let's go.
Oh, well, this is a very specially designed test made by the geniuses here at the Podiversity. There are no right or wrong answers.
Oh, I love that.
We are going to use your answers to try and match you to classes and extracurriculars and maybe some roommates or something here at the Podiversity.
That sounds fun.
The first question, I think I might know the answer. How would you describe your current relationship with the universe?
My current relationship with the universe is complicated. I think we're friends. I think the universe and I are way friendlier than reality and I are.
Love. That's valid.
So, like, I I would like to say I'm a friend of the universe. The universe and I get along usually until reality gets its ugly claws in there and reminds us that it's also part of the universe. Then I get a little annoyed, and so does it.
And you know that about the universe, so you really are linked. You're close in that way.
Yeah, we vibe.
That's so nice, because a lot of people feel like they are friends with the universe, but the universe might not necessarily be friends back to them.
I get that. I feel like the universe and I are really close friends in the way that sometimes your close friends can hurt you and insult you and let you down and disappoint you, but you're still friends. And like you'll work it out eventually.
Oh, that's so grown up of you.
I've worked hard on it.
It shows. Okay, the next question then. Do you have a favorite equation, Bex?
I like the Pythagorean theorem because the word Pythagorean is a fun word.
Yeah, it just feels right. Like when it comes out of the mouth, it's like a pleasant shape.
Yeah, great mouthfeel.
Oh, I had never thought of using mouthfeel in the context of just language, but yeah. The mouth also feels words.
Oh, big time. The mouth likes words a lot.
Truly. When do you think is the last time you used the Pythagorean theorem?
I feel like I have bastardized the Pythagorean theorem recently. Every time I do something in D&D where I have to be at a different elevation and have to see if I'm still in the correct distance from the target, I just go, I'm going to hypotenuse in this bitch.
Yeah.
So, like, I feel like I use it without actually doing the equation and utilizing the steps. I just reference it because I love it.
So you reference it and everyone's like, oh, okay, yeah, that's the hypotenuse, whatever you say it is.
Yeah, exactly. I'm like, I'm going to do the hypotenuse in this bitch, and it's going to work.
Oh, I love that. See, I play D&D with four other scientist academics. And so we actually have used the Pythagorean theorem to make sure that our spellcasters are like within the right range for something.
Good.
And we calculate it.
That's what you're supposed to do. Like that's the entire point of making a war game that's math-based. You're supposed to be able to nerd out like that. I just go, I'll make it work. If it's not working, I've moved X amount of feet closer.
See, I think that's how it should be. I don't want to have to do math in my time off.
That's fair.
Well, that's a good one. And I think that's a good application as well.
Thank you. I'm proud of it.
Are you proud of your zodiac sign? Do you feel like your sun sign matches who you are as a person?
I'm going to let you guess what my sun sign is.
Okay. Caveat, I know very little about any sign other than my own. So...
Wait, what's yours?
I'm a Capricorn.
That's my rising.
Okay. Okay, so I wasn't getting very strong Capricorn vibes.
Nope.
But I would guess... I want to guess something that I haven't guessed in a while. I'm going to say Sagittarius.
Ooh, fire. Very close.
Yeah?
Leo.
Okay, but no. Leo. I've recorded with 2 Leos today.
We are very entertaining, and we like to think that. We find ourselves funny so that no one else has to. It's really convenient.
That is good. You don't need a crowd. You're your own.
Exactly. So yes, I love my star sign. I think that it fits very well. I'm very boisterous. Let's go with that.
Okay, I love that. I now know a little bit more about Leos.
We're a lot in usually complimentary.
The first co-host that I had for this show, Corinne, she was a Leo, and that was a nice pairing.
I think that Capricorns and Leos go well together. It's like an earth and a fire thing. The earth can smother the fire when it's necessary, but it can also protect from the fire. With enough mud underneath a fire pit, you can keep leaves green.
Yeah.
And, like, I feel like they can also, Earth can still fuel a fire when it's necessary. I don't know. I think they go well together.
I like that a lot. I am an Aries moon and a Taurus rising. So
nice.
It's a lot of fire in there.
Got a lot of earth, got a lot of fire. It's really good.
Yay.
I'm a Leo sun, Scorpio moon, Capricorn rising, so... Oh, no.
What's Scorpio? Is that Earth?
Water.
Water.
I know, it doesn't make sense.
Scorpions can be in water, too. That's fine.
Scorpions scare me.
As they should. That's wise, Bex. Okay, so you're a Leo, and it fits. Bex, what's the best planet? What's the Bex planet?
What's the Bex planet? I'm not going to do a deep pull from something in the Alpha Centauri system, because that would just be a little bit too ridiculous. I'm going to say Pluto, because Pluto deserves more respect.
I agree. I love Pluto. I have all the planets tattooed on my arm, and even though I got the tattoo in like 2015 or something, Pluto's there.
Pluto should always be there. Look, even a dwarf planet, a mini planet, still a planet.
Thank you. Yeah, I agree. 100%. What is it about Pluto besides the respect thing that you like?
I love that it's distant and cold. I don't know if that's telling about me in terms of personality or what. This
is a get-to-know-you quiz. I think you're doing it right.
I do. I like that it's distant and cold and small. And, like, I think there's something so sweet and charming about that, because it still wants to be part of the family. It still wants to be in the orbit. It just needs its little space. It needs its alone time. It needs its, like, I'm the runt of the litter, and that's okay.
Another piece of information to add to that is that Pluto is not always the most distant planet in the solar system.
Really?
Its orbit is eccentric enough that sometimes it's closer than Neptune. So it's yeah, Pluto wants its distance and it wants its alone time, but it also wants to come in with the group every once in a while.
Oh, that makes me love it even more. Classic introvert. Just like, I need to be part of the group. No, I'm done. No, I need to be part of the group. No, I'm done.
Yeah, that's one of my favorite things about Pluto.
Oh, I love that. And I love that you said it's eccentric. I love anything and everything that can fit under the category of eccentric. So even more of a Pluto fan now.
Yeah, well, all of the orbits are eccentric. We don't have any perfectly circular orbits in our solar system.
Excellent.
If you could witness any event in space, a supernova, a black hole collision, maybe a planet forming, anything, what would you want to witness, assuming you're completely safe?
Thank you for the caveat. I don't know. There's something about collisions, just all different types. A collision of two asteroids, a collision of two planets, a collision of an asteroid into a planet, a collision of a moon into a planet, an asteroid into a moon. I would love to see all different types of collisions. And you mentioned, like, black hole collision. I feel like that would be the most epic of collisions. But I would also really want to see, like, the small ones. Because space is a vacuum and I don't know what that would look like. I'd be so curious.
That is a really great answer, because one thing we talk about as astronomers is that space is so big that even when things like galaxies collide, the individual parts of those galaxies usually have no contact with each other.
Yeah.
We run this calculation early on in our training to see how many stars will collide when the Milky Way and Andromeda do in about 5 billion years. And there are trillions of stars. There are at least 1 trillion stars involved in this collision, and yet maybe a handful of them will actually touch. So
Wild.
You wanting to see one of those, like, smaller collisions is a great answer, because it's so rare and could teach us a lot.
Yeah.
Okay. So maybe would, like, planets colliding in one of those galactic collisions sound interesting?
Yeah, for sure.
We'll do that for you. Or we could just take you to the center of our Milky Way galaxy, and there the stars are a lot closer together, and they're moving on weird orbits that aren't circular. Like, they're moving on rosettes and on box-shaped and, like, figure-8-shaped orbits.
Oh, they're dancing. They're doing the box step.
Yes. Oh, I love that. Yeah, they're dancing. And there are more opportunities for collision there, so...
Ooh, I'm into that.
We call it the bulge. The bulge of the Milky Way. Because we're children.
I love that. I want to visit the bulge.
Yes! I wrote my dissertation on the bulge.
You are so cool.
Okay, next question. Imagine you're an astronaut. Maybe you're going to the Milky Way bulge because you want to see some collisions. We're about to launch you into space. What song are you playing during blastoff?
Highway to Hell.
Oh, you knew that immediately. Yeah.
Highway to Hell.
I see it.
I feel like Stairway to Heaven would be too chill and a little too on the nose. And I think Highway to Hell would, because first of all, I'm Jewish, so I don't, hell isn't really a thing for us. But like the mythos of hell, I'm not sure if I'm buying the whole, it's hot, it's all on fire. Wouldn't it be absolutely hellish to be stuck in a freezing cold vacuum?
Yes, I
think
so.
Just a void of nothingness? And your biggest threats are that frozen nothingness and big old holes full of extra nothingness that are unknown. I feel like, the heavens could actually be hellish. So I'd go to Highway to Hell.
Ooh, that was like a poem that you just said. That was nice. The heavens can certainly be hellish. Maybe Dante was just like a huge space nerd.
I love that idea.
Yeah, he was looking at the planets and he was like, oh, the 9 planets. These are the 9 circles of hell.
Absolutely. I think we should just take Dante's Inferno and rewrite it as visiting the planets.
Okay, well, I'm free next week if you want to get started.
I'm in. Let's do it.
Fantastic. Final question, Bex. Anything in space or here on Earth in the past or the future, what's scarier than a black hole?
I think those black holes in the ocean are pretty...
Did you say black holes in the ocean?
There are some black holes in the ocean.
I need to know so much more about this right now.
Yeah. I need to go down this rabbit hole again because it's been several months since I have. Deep ocean. First of all, deep ocean on our planet is less explored than outer space, which I think means they found something and it scared them so badly that they stopped exploring.
That's how I would do it.
Mm-hmm. And so what they've found out is there are these basically whirlpools in deep ocean that essentially function as aquatic black holes.
Just sucking everything in.
Mm-hmm.
Where does it come out?
That's a great question.
Because if the black hole metaphor gets carried far enough, it doesn't. It just gets, crushed under the pressure.
That's what I'm wondering. And maybe that happens in outer space, too. I don't know, but I don't know if there's anything scarier than a black hole that I can think of, except for a black hole on the planet you're living on.
And in water.
Yeah.
Because the ocean, to me, is scarier than space. So put a space thing in the ocean place? No, thank you.
Yes, we get it. The space, it keeps expanding. Yeah. The ocean is most of our planet. Oh, my God.
Wow. My entire evening is planned for me now. I'm going to have to look into these ocean black holes, and then I'm going to have nightmares. So thank you for that.
You're welcome. I also love the idea that octopi, because scientists really don't know what they could have possibly evolved from, are aliens, and there is a connection between our oceans and our skies. I think there has to be. That's way too cool.
Well, a lot of scientists think that we get a lot of our water from space, from comets and asteroids bringing it and impacting on Earth.
Oh my God, that would make so much sense. Yes.
We're all just trading and borrowing stuff from our planetary neighbors.
We're all made of the same cosmic dust.
Yeah. We're all made of stuff that you see produced in those really big collisions.
Yeah.
I think your answers were great. You're going to fit in so well at the Podiversity.
Ooh, I'm excited to enroll.
You've already enrolled, friend. You're already here.
Oh, yay. It's the ADHD. I never remember when I'm doing what.
Okay, we have great accommodations here at the Podiversity, so we can get you note takers. We can get you people who will remind you about your schedule and when you have classes. We have everything.
Yes, please.
We want to take care of our students here.
I feel so loved.
All right, so now that I know you a bit more, now that the listeners do, we can get into talking about Alpha Centauri. And I want to address the Centaur question right up front. Yes. Alpha Centauri is a system of 3 different stars, and it appears to be in the Centaurus constellation from our point of view. And we like to name objects in the sky after the region that they're in or the constellation that they're in. And so it is the first big star system found in the Centaurus constellation. So Alpha being number 1.
It's the Alpha. It's the leader. It's the one to trust.
I don't know if I would trust it. The Alpha Centauri system is pretty trickstery.
Really?
It has befuddled human astronomers for almost a century. We've been really paying a lot of attention to this system for a long time.
Wow.
One of the first tricks is that there are 3 stars, but we can only see one bright point of light. And so for thousands of years, maybe up to 1 million years, when humans looked up at this star system, they saw it as one single star. And when you combine it, it looks like one of the brightest stars in the sky, either the 3rd or 4th brightest star in the sky. But it's actually 2 stars with a 3rd one hanging out around them that we can't see.
Oh, It's a polycule.
It is a polycule. Yes. This is one of many reasons that I say space is very queer. Space is poly. Space doesn't know about gender. Like, space is such a rainbow. It really is. Okay, so it's a 3-star system, but for most of history, people only knew about those 2 stars, which they thought were one. It's in the Centaurus constellation, which is to the south, so it's not visible above 29 degrees north. That's the latitude where it gets cut off. But Earth has wobbled over time. So back in the time of the ancient Greeks, when Ptolemy was writing down the constellations and he was marking different important stars that he could see in the sky, Earth was wobbled a little bit more towards that system. So Ptolemy could actually see Alpha Centaurus, and it was listed in his Almagest, but then the Earth axis shifted, and now the northern hemisphere, most of it cannot see this system.
Do you think it's ever going to wobble back?
Yeah. The wobble is a circle. So, in like 10 to 20,000 years, yeah.
Wow, that's too many years.
It's a lot of years. Definitely not within our lifetime.
Nah.
But you can travel to the south and you could go see that one star and you'd be like, that's it. That's exciting. If you want to do that, it's visible in the spring and the summer because for the rest of the year, it's behind the sun, so we can't really see it.
Interesting.
Or like it would be up during daytime, so we couldn't see it because of the light pollution from the sun.
That rude sun.
So rude. So we've known about those 2 stars forever. We didn't realize that they were actually 2 distinct stars until 1689, when a French astronomer, Jean Richaud, was observing a comet. And the comet happened to pass by that point of the sky. And so he saw it through his kind of brand new telescope. Telescopes had only been invented that century.
Wow.
He was the first person to look at this star through a telescope and see that it was 2 and not 1.
Wild.
It was only like the 3rd binary star system to ever be discovered. But now we know that most stars aren't alone. It's even somewhere up to like 75 to 80% of stars we can expect to have at least one companion. So our sun is really weird in that it doesn't have another star hanging out nearby.
So basically, Alpha Centauri, if you were to live on a planet there, you would have 2 suns?
You would have 2 or 3 suns.
Ooh.
Yeah. I'm getting to the 3rd one now.
Just while we're sticking with the 2, I'm wondering if, is that where Superman comes from? Is that where Krypton is?
Ooh. What do we know about Krypton? What do they tell us about the planet in the media?
It was a lot like Earth, but more advanced, and it had 2 suns, which is exactly why Superman would not have had pale skin.
Oh, yes. Then in a way, yeah, it is like Krypton. Although there are many ways that you could be a planet orbiting 2 suns. You could have the 2 suns in the middle, and then the planet is outside both of them. You could have the planet that's like figurating between the 2. You could have a planet that's orbiting one of the stars, but that star is orbiting the other. So you get like weird orbit things.
Like a moon star.
Like a moon star, yeah. I like that. But that's essentially what this whole system is. It's moon stars for the stars themselves. And it took us a long time to even wonder if there were planets around the Alpha Centauri system. But for a couple hundred years, we knew that there were these 2 stars, Alpha Centauri A and B. We call Alpha Centauri A Rigil Centaurus. It means the foot of the centaur because it does look to be the foot of the centaur constellation. And then Alpha Centauri B is called Toliman, Toliman, and I'm pretty sure it comes from the old Arabic word for the star.
Cool.
And then in 1915, astronomers were looking at this system with more powerful telescopes and other types of instruments, and they discovered a 3rd star that orbits really far away from those first 2.
Ooh.
The astronomer his name was Robert Innes. He was a Scotsman.
Innes.
And he was looking at these photographic plates. We used to take pictures of the sky on these giant metal plates where the image would be like engraved on the plate, so it would end up with a little divot where a star was or where a galaxy was, depending on what you were observing. And he was looking at these plates at different snapshots in time. So a plate from like Monday night versus a plate from Friday night, and comparing the differences. Because when you do that, you see what we call transients in the night sky, things that move or change from one night to another. And when he compared the plates, he saw that there was this one star that moved over the course of their observation. And the way it moved was very similar to the way Alpha Centauri A and B moved. We call this proper motion because we have to be really careful in astronomy. Perspective is so important. Just because something appears to move, like 5 degrees across the sky doesn't mean anything unless you know how far away that object is. And it means even less if you don't know how that object is moving relative to like your own object's motion, because the sun is also moving around the galaxy. So we have to take all of that into account. And when we do, that's called proper motion, like the actual amount of distance that this star seems to have moved. And when they did all of that math to figure out how Alpha Centauri A and B were moving, it was the same amount that this new star was moving in 1915. So kind of without much more information, without much more confirmation, Robert Innes was like, no, that's part of the Alpha Centauri system, and it's obviously closer to us, so I'm going to call it Proxima Centauri, because it is the most proximate object to our system.
Smarty patootie.
It's a little bit jumping the gun, I think. Like, he could have waited for a bit more information, but it's fine. It was true, and it was confirmed, like, a few years later that this was part of Alpha Centauri and that it was closer to us than the other 2 stars.
So he lucked out.
He did. I mean,
a little bit of skill, a little bit of luck.
There wasn't much else it could have been.
Fair.
So, yeah, he lucked out, but he was also making a very well-educated guess.
We love an educated guest.
Certainly. Hey friends, Bex is learning how to say, hello, how are you? Where is the library? In bee dance language. That seems like it might take a little bit, so I'm going to let them have that time and use this as an opportunity to share some messages with you. The first is a podcast recommendation. It's another show in the Multitude Collective, and it's called Attach Your Resume. This is a new show from Multitude that interviews online creators about how their jobs work and how they got there. They've talked to Hank Green. It was very cool. He got kind of emotional. Like, I really enjoyed it. You can hear the personal stories behind seismic events in digital media and learn what concrete steps we can take to build a sustainable media landscape. And the show is hosted by 2 longtime podcasters and business owners, Eric and Amanda of Multitude. Attach Your Resume proves that the best credentials for deciding the future of media is actually making stuff. They put out new episodes every other Thursday until they run out of episodes and have to go make more. So subscribe now to Attach Your Resume in your favorite podcast app, and that gives them more incentive to keep making episodes because they really are fantastic. So check out Attach Your Resume wherever you get your podcasts. Okay, now I really want to thank all of my patrons. I could not make this show without your support every single month. Really, it makes a world of difference. And I want to give a special thank you to my Sun-like stars, Scott Reynolds, Augustin, Tom T., Mark Mahoney, and Nicole Bartlett. And a new Sun-like star has just formed in the sky. So thank you and welcome to New Dude. You're all so hot, like 10,000 degrees hot. You all can hear your name on the show. You can support an independent podcast and get research notes for most episodes by joining my Patreon for $5 a month. Brighter, hotter tiers, like my Sun-like stars, pay a little bit more for extra perks. And I offer annual memberships that give you a 13% discount across the entire year. So sign up now at patreon.com/palebluepod. And if you can't support with your money, that's not a problem at all. You can help the show grow by sharing your favorite episode with someone who you think would like it. That's the best way to help our show expand beyond its current atmosphere. All right, Bex is shimmying back. Ooh, all right, Bex. So let's return to Alpha Centauri. So now I have a little bit of information about the stars themselves. It's A and B, which are really close to each other. They actually have a very eccentric orbit. So at their closest approach, they are 10 astronomical units away from each other. So to put that into distances that we're more familiar with in our solar system, at the closest approach, Stars A and B are as close to each other as the Sun and Saturn are. Yeah, at their closest.
Yeah.
And then at their furthest, they're about as far apart as the Sun and Pluto are.
Ooh. At Pluto's furthest?
At Pluto's average.
Okay, cool.
Yeah, stars A and B range from about 10 astronomical units to 35 astronomical units away from each other. Still pretty close.
What's an astronomical unit?
It's about 93 million miles is one
Wow.
astronomical unit, or 1.5 times 10 to the 13th power centimeters, which is what we learned in school.
That is too many centimeters. No, too many centimeters.
So many. I thought it was hilarious and stupid that we used one of the smallest units to measure the greatest distances, but you know what?
It feels correct somehow.
It's what it does. So that's 1 AU, is the distance between the Earth and the Sun.
Cool.
And so A and B, they have that kind of elliptical orbit. It takes them about 80 years to complete one orbit around each other. And this type of system is really interesting because they're both about sun-like stars. Star A, which is called Rigil Centaurus, it's a sun-like star that's about 10% more massive than our sun. It's a little bit hotter, and it's about 50% brighter. So it's much brighter than our sun, but still has a lot of the same physics going on inside of it. And it's going to have the same end life stages as our sun. Star B, or Ptolemy, is, again, very sun-like, but slightly smaller. It's about 90% the mass of the sun, and it's about half as bright as our sun. This type of system, when you have at least one sun-like star with a close companion, ultimately will probably end up becoming a supernova. And it's not because the individual stars are massive enough to create a supernova. It's because eventually one of these stars will become a white dwarf. Maybe both of them will, but not at the same time. So after the star burns through all of its fuel, it's going to puff up into a red giant phase. It's going to shed a bunch of its outer layers, and what's left in the middle will be a small but very dense white dwarf. It's important that it's dense because it has strong gravitational attraction. So what it's going to end up doing is eating material from its companion star. So eventually star A is probably going to start eating star B.
Ooh.
Once it eats enough, it's going to reach this threshold at 1.4 times the mass of the sun. At that threshold, weird things start happening with carbon burning and with the types of fusion that you're doing inside the star, and it will explode as a type 1A supernova. So that's what we can expect, I think, in up to about 10 billion years. Definitely less, but that's the lifespan of a sun-like star. So in about 10 billion years, maybe there will be a supernova there.
Fascinating.
Yeah.
And what'll happen to Proxima when that happens?
That's a great question. It is most likely not going to be ripped apart by the shock wave. I don't think it's that close. But any planets that are around Proxima are going to get cooked. Not destroyed, but their atmospheres might be blown away. If they maintain an atmosphere, then it's going to be ionized, so all of the particles in it will have their electrons stripped away or added to, so they'll become charged particles, which is usually not good in an atmosphere. So Proxima, the star, will be fine, but any life that exists on the planets, probably not. Yeah,
makes sense.
Yeah.
And they have time to figure that out.
They do. They have a long time to figure that out, if there's anyone there. We'll see. I'm going to get to that because we've been looking. So Proxima itself is much smaller and dimmer and cooler than the other stars. It's what we call an M-dwarf star, about 10 to 12% the mass of the sun. It's not visible with the unaided eye, so you would need a telescope or a pair of binoculars to see it, and it's really far away from the other two stars. So if A and B are on average 25 astronomical units away from each other, Proxima is 13,000 astronomical units away.
Wow, that's a lot of units.
It is a lot of units. 13,000 astronomical units is actually bigger than our entire solar system.
That's too big. That's too many centimeters.
It's too big. It takes over 500,000 years for Proxima to orbit stars A and B.
Wow.
So it's really far away, and that's why it really is the closest star to us, and it has been since we discovered it, and it will be for a long time, because it's going to take 250,000 years for it to be farther away than the other two stars.
Fascinating.
And we know that Proxima has at least 2 planets around it. We have a candidate for a 3rd planet that we're still actively trying to confirm. And the other 2 stars have had many candidates come through, but they've all been psych outs. So I have some of those stories. Starting with the 2 that we know are confirmed around Proxima. In 2016, the European Space Observatory had a spectrograph in Chile called HARPS. It's probably like a terrible acronym with lots of nested words and everything. But it's a spectrograph, which means it takes light in and it splits it up into the different wavelengths to measure how strong the light is at those different wavelengths. And that gives us information about what type of molecules and elements we find in whatever light target we're looking at. So they were looking at Proxima, and they noticed that we call it a radial velocity curve. We noticed that the velocity of the star was different than it would be if there weren't a planet around. This is one of the ways that we look for planets, because the planets will actually have a slight gravitational tug on their star and cause the star to wobble or dance around a little bit.
Wobble, baby, wobble, baby.
Yeah, the stars are all doing the wobble out there. And astronomers can look at their dance and figure out how many planets are there and how big are those planets. How massive are those planets compared to the star? This was discovered as part of a big astronomy campaign called the Pale Red Dot Campaign, where astronomers around the world were trying to figure out if Proxima, the pale red dot, had any planets around it. And they found one in 2016. It's about Earth-sized. It's like 30% more massive than the Earth, and it orbits Proxima every 11 days, which sounds very short. It's a very short year, but because Proxima is so much dimmer and cooler than our sun, that's actually where the habitable zone is. Yeah. So this is a kind of Earth-like planet in the habitable zone of Proxima.
Nice.
Yeah. That was the first one we found. People were really excited about that, and it was kind of encouragement to keep up the search. There were a couple more fake outs around Proxima, but in 2020, we discovered a new planet, again, discovered by European Space Observatory scientists. And they had to combine data from a couple different instruments. They used that same HARPS spectrograph to get the radial velocity of the star. Radial velocity is how fast the star is moving towards and away from us. So we can't see it from side to side, but we can see towards and away. That happens because the star's spectrum, it really does kind of bounce back and forth. It gets redder as the star moves away from us, and then it gets bluer as the star moves towards us, and we can measure how fast it's moving. If you want to get the side-to-side information, that's called astrometry, and it was only in the last, I guess it was launched in 2013, so only in the last 10 years that we have an instrument that gives us really good astrometry, and that's the Gaia spacecraft. I used some of this data in my PhD dissertation, so I love Gaia.
Cool.
But when you combine the towards and away from us information and the side-to-side information, you actually get a much more holistic view of this star's motion, so you can get a more accurate read on what type of planet might be tugging on it. And they found a 6 Earth mass planet, but that's an upper limit, so up to 6 times the mass of the Earth.
That's a big planet.
It's a big planet. We call these mini Neptunes.
Whoa.
Or super Earths or mini Neptunes, but at this size, it's almost certainly not rocky anymore, so more like a Neptune than an Earth.
Interesting.
So it's pretty massive, it's pretty big, and it orbits Proxima every 5 years. So definitely outside the star's habitable zone, because it's on a pretty wide orbit. And it was confirmed, actually, so they found the RVs, the radial velocities, and that's how they discovered it. But you always have to confirm a planet with a completely independent method. So if you find a planet using radial velocities, you have to confirm it using transits or imaging or microlensing or something else. Or a similar method, but on a very different telescope. This one was confirmed using old Hubble Space Telescope images from 1995.
What?
They looked back and they found an image that Hubble took of Alpha Centauri, including Proxima. And in that image, they were able to find a picture of this planet. It's one of maybe a handful of planets that have been visually confirmed.
Wild.
Yeah.
That's so cool.
I know. Thank you for nerding out with me. We don't have any confirmed planets for stars A and B, but we do have some pretty decent candidates. Star A had a candidate that was found in 2021. It's a potential mini Neptune, so bigger than Earth, smaller than Neptune. And it has a year-long orbit, so probably pretty Earth-like if it's there. And they found that through direct imaging. So they took a picture of it, but not in the optical. They had to take a picture of it in the infrared part of the electromagnetic spectrum. But it's still a picture.
Yeah.
And in order to confirm it as a planet, they're waiting on some follow-up observations from JWST.
Got it.
Have you heard of JWST?
No, but I now have the acronym and I can look it up.
JWST... It stands for the James Webb Space Telescope.
Oh.
James Webb was a terrible person, so
Yeah.
I call it the Just Wonderful Space Telescope.
Just wonderful. I love that. It's just wonderful space telescope.
Some people also call it the Jelly Welly Space Telly.
Okay, sorry, that one wins. I'm excited about the Jelly Welly Space Telly.
Yes. So hopefully in its next cycle or two, it will look at Alpha Centauri A and see if there's actually a planet there.
Come on, Jelly Welly, tell us what we need to know.
Fingers crossed. So many people around the astronomy community are keeping their fingers crossed for that, I assure you.
I'll join.
And then for star B, we found a candidate in 2012. It was about Earth-sized, and it orbited every 3.2 days.
That's fast. Yeah. That's too fast.
It's really fast. Remember, this is a star that's almost as big as our sun. Mercury orbits our sun every 88 days. This thing orbits every 3 days. It's orbiting twice a week. Too much.
Too many.
It's too much.
No.
So it would have been a super hot planet, essentially a magma lava world if it existed, but it was discredited in 2015. It was found to be just kind of like a random consequence of the way the team reduced and cleaned out their data. So it was just like a mistake.
Rude.
But honestly, probably for the best.
But honestly, so are some offspring. So it could still be a mistake and also be real.
Yes.
Just I'm so
You're
sorry.
Right. No, I love that. I was a planned baby.
Me too.
I kind of wish that I hadn't been, but because they shouldn't have. But yeah, they did, and here I am. So there are ongoing searches to look for more planets around all of the stars in the Alpha Centauri system. Just a few instruments that we're using, that HARPS spectrograph. It's down in Chile, and it's a really powerful spectrograph. Chile has a lot of astronomy infrastructure there.
Cool.
There's the Jelly Welly Space Telly, which is out in space, and it's doing a really good job of looking at the atmospheres of planets. It's powerful enough to do that. And then there's Chiron, which I love as a name.
Yes.
But I hate it as an acronym.
Oh, it's an acronym?
It's an acronym, and here's what it stands for. It stands for the CTIO. That's an initialism. CTIO is the Ceratololo International Observatory or something. So already terrible.
No.
CTIO, High Resolution Spectrograph. Spectrograph gets no representation. Where are they getting the ON? Is it from the end of resolution?
Just name it Chiron and have it not have an acronym.
Thank you. Yeah. But no, they tried to backronym this and it didn't work. But it is going to hopefully do a good job of looking at the radial velocities of these stars so we can see if there are planets around them. But then the one that I have the most hope for is called Ptolemy. So it's named after the star B. Mm-hmm. This is an acronym, and I think that this is a good acronym, actually. It stands for Telescope for Orbit Locus Interferometric Monitoring of our Astronomical Neighborhood.
Oh, I like that. It's
right?
wonderfully excessive.
I feel like they must have spent so much time working on that.
Yes, and I appreciate the effort. Like, even if I can't remember what the acronym stands for, I can remember Ptolemy.
Yeah.
And I can remember that it's a long acronym, and they put work into it, and that I have respect for.
Mm-hmm. Yeah, they also spell neighborhood the British way, and it's
good.
Nice.
Yeah,
I like a
when you do
U.
that.
So, in the next few years, keep an eye out on Ptolemy to see if it discovers any planets in this system. There are other funding sources, too, for this search. That's all the, National Federal Space Agency funding, but some private companies are starting to fund this search. Have you heard of the Breakthrough Initiative?
No.
A bunch of billionaires got together to try and fund astronomy research. They're especially interested in funding the search for extraterrestrial intelligence, and they have funneled hundreds of millions of dollars into different initiatives of theirs. Honestly, if they're gonna have that much money, I'm glad they're giving it to science.
Truly. Don't
Yeah.
fuck with billionaires, but I do like it when they give it to science.
They shouldn't exist, but if they're gonna, at least do nice things with your money. So Ptolemy is a little bit different than the other spectrographs and the other surveys that I've talked about. It still uses the radial velocity method, so it's still trying to figure out how fast these stars are moving towards and away from us, but it's almost going to be like it's squinting. So instead of having a very focused beam, it has a spread out beam, which actually makes you more sensitive to motion and less sensitive to the light, which is fine. We know how bright these stars are. We care more about how they're moving. So it's like Ptolemy is squinting to get a better view.
I relate to that whenever I don't wear my glasses.
Yeah, because it helps.
Yeah, it's really annoying.
Yeah. We're also trying to go there.
Whoa.
Some people are trying to go to Alpha Centauri.
Wait, but wouldn't that, I think I looked this up, wouldn't that take like 119.5 million or thousand years?
Yeah. So these stars they're the closest stars to us, but they're more than 4 light years away. Proxima Centauri is 4.2 light years away.
So if we can learn how to travel at the speed of light, we could get there in 4 years.
Yes, exactly. And that's what people are trying to do, or at least get close to it. So that Breakthrough Initiative with all of the billionaires funding scientific research, in 2015, they started Breakthrough Starshot, which is this program to try and take a nano spacecraft, so something that is very, very tiny, and propel it towards the Alpha Centauri system using the pressure from the solar wind, just pushing it out into the interstellar medium. They think that they could use the sun's power to reach 1/3 the speed of light.
Oh, that's still slow though.
It is still slow. It would get there in 12 to 15 years.
Okay, that's better than 120,000.
Exactly. People who work on this mission could be alive to see the data.
That'd be cool.
If it works.
Yeah.
Back in 2017, there was a Republican congressman from Texas who ordered NASA to do something similar. I imagine he had heard of the Breakthrough program, and he was like, no, we need to have NASA doing this. So he told them to design a probe that could reach 10% the speed of light and be sent to Alpha Centauri. That's not happening. NASA's not doing that.
No.
They don't have the resources. They don't have the inclination.
No.
And there are other companies that are better suited for that. So that just kind of got ignored. But even though we can't get there anytime soon, we are still studying the system, not just to look for planets, but to look for life on those planets. So we're studying them with radio waves. We're studying them to try and see if there are organic compounds in the atmospheres of the planets that we have discovered. But one more efficient way that we can try and find extraterrestrial life is by looking for or waiting to receive technosignatures. These are patterns of radio waves or patterns of light emission that signify that there's some sort of intelligent being there because it's not following a natural pattern. Back in December of 2020, another breakthrough initiative, this one is called Breakthrough Listen, and they work very closely with SETI, the Search for Extraterrestrial Intelligence Institute. They announced that they had received a radio signal coming from Proxima Centauri. And everyone was real excited. They were like, oh, this is like the wow signal all over again. We need to, get Carl Sagan from the grave and have him write a new contact for this. But it turned out that it was just human Earth-bound radio interference that the telescopes caught, and that is why we are very careful about confirming things at least twice before we announce them.
That makes sense.
Yeah.
That makes a lot of sense. Mm-hmm. Also, what if intelligent life is out there and it's just intelligent enough to utilize natural patterns?
Right. Or what if they don't use light? What if they're not a visual species? What if they are very smart and so smart that they know to keep to themselves?
That's
There's
exactly
so
what
many
I was thinking. What if they're so smart to know that we are not worth reaching out to?
We're not.
No.
That's what I learned about Proxima. Given what you now know about the Alpha Centauri system, I'm wondering if you would change their names, the names of these stars.
I think so.
What do you think you would change them to? There's Rigil Kentaurus, there's Ptolemy, and Proxima. I am bothered by the fact that there's no, like, consistency. That it's, none of these things are like the other.
Yeah. Well, we could name them silly names like Reggie, Tolsky, and Proto. Like Frodo, but Proto.
But, yeah, we could.
We could name them like silly names, or I think I would name them to keep in the vibe of space and mythos. I think I would go for either 3 different famous Cyclopes names, like Polyphemus and I'm blanking on the other 2 that I was thinking of, but it doesn't matter. No one's as famous as Polyphemus at this point.
True. I named my clarinet Polyphemus in middle school.
Good. It's so good, right? Mm-hmm. I might either go for 3 Cyclopes or Cyclops or 3 different sun gods, like Ra and Apollo and...
So you have like Aditya. Let's do like a Hindu or Vedic sun god.
Yeah. Right? And then like whichever one is closest, maybe the one that was utilized the fewest thousand years ago, or the one that's still utilized today, or and still worshipped today in more wider net, and then as it goes farther and farther back, the ones that are older and older.
Yeah. Oh, that's such a good idea. I'm going to contact the International Astronomical Union and be like, we need to switch this up right now.
Get them on it.
No one can remember Rigil Kentaurus.
No. I'm going to call it Reggie, though.
They cooked with Proxima, though.
They did. They cooked with Proxima. I'm going to call it Reggie and Ptolemy. I'm not going to remember Regil Kentugi. I like these new names. Anything still wandering around in your mind as a curiosity about the system? If I were to see it in the spring, what would I see? Where would it be?
Oh, yeah. If you want to see it, go to the southern hemisphere. It's at a declination. So its north-south position is about negative 60 degrees. So if you go to a place on Earth that's 60 degrees south, it will pass right over your head in the spring and summer.
Cool.
It will look just like a very bright star. You won't even be able to see that it's 2 different ones without a telescope or pair of binoculars.
Interesting. That's really cool. I'm going to have to go on a trip in the spring.
I highly recommend the astronomy tourism in Chile. They have some really cool observatories that you can visit. I did like a whole north-south observatory tour a few years ago, and they're in like the deserts, so you have beautiful skies. I saw my shadow cast by the Milky Way.
Whoa!
I saw the large and small Magellanic Clouds. I saw the big inky voids that you can see from the southern hemisphere in the path of the Milky Way. Like, so cool. So best skies I've ever seen have been in the southern hemisphere.
The sky is amazing. I gotta go. Let's do this.
Yay!
Thank you.
Oh, thank you for joining me. Thank you for such a fun episode. Before we wrap up, could you take a second to brag about yourself? Tell us what you're working on and where people can find you online.
Yeah, I'll give that a shot. I'm working on bragging about myself. We're working on that in mental health. Let's go. My pride and joy right now is the Wandering Path podcast. You can find
It's so good.
Oh, thank you. You can find it anywhere you get your podcasts. It's an actual play Dungeons & Dragons game where we created the world. We use a lot of the rules from Dungeons & Dragons 5e, and then we also use compendiums. It helps to know the basic how D&D works, but you don't need to listen to the podcast. It is just long-form collaborative storytelling with a little bit of prep, but mostly improv. And I'm so proud of it. It sounds so good, so beautiful. Our game master is a sound wizard, as you well know.
I do know. I'm quite familiar.
Yeah, they're so talented. It's so annoying. And it's my favorite thing. I love it. It provides community. It provides joy. It provides mystery. It's the favorite thing that I think that I've ever worked on in my career. And I've been really lucky to work on some really cool things.
Wow, that is saying so much.
Yeah.
But I'm not surprised. Misha's fantastic.
Misha's
and I recently recorded an episode with Moiya, so yes. It seems like the entire crew is, even outside of the Wandering Path, just great people.
Yeah, we really lucked out. It's always like, no, we're buddies because we like each other as people. And the reason we're playing this game and doing this podcast is because we like each other as people, and we all want to make something cool because we like each other. That feels really nice.
That's so beautiful.
Yeah.
Yay. Any links or handles you want to share?
Wandering Path Pod on all socials, I think, unless the hellish app, formerly known as Twitter, might have said that we had too many letters. It doesn't matter. Wandering Path Pod, just about anywhere, wanderingpathpod.com. You can reach out to us. We're also on Patreon, and we just love making weird, silly story stuffs.
Yay! And I love listening to weird, silly story stuff, so it works out in my benefit at least.
Yes.
Awesome. Well, those links are down in the show notes, friends, so check them out. And you could hear Bex's voice in addition to here on Pale Blue Pod. That was fantastic.
This is so much fun.
I had so much fun. I would like some honey now. And to meet the queen. I think that maybe the queen would enjoy hearing a bit about these 3 stars that we just discussed.
The stars are dancing, the bees are dancing. I feel like they'd get along.
Yeah, we can promise to rename a constellation after her, and then I think we'll get an audience.
I'm sure. Let's go get honey.
Well, listeners, no matter how many royals you've met in your lifetime, you're still space. Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.